Diary entry number 2. Today is the 19th of October, and I will be doing a live static analysis. During this time, I will try to document my steps and talk through the steps as well. The aim at the end of this for my documentation will be to have a video and a write-up. And the aim for the static analysis is to be able to identify the file. So file identification, do a quick overview of the PE header file, and then do some string analysis to understand the functionality of the malware. I've already launched my VM. This is Flare VM, and I have the file. I have downloaded the file. Here, please note that this VM is completely segregated from the host. There are no network connections and no files shared. However, because I will be using a clipboard, I have activated the guest to host shared keyboard functionality or feature. So let's talk a bit about the file. This file, I got it from one of the videos for Tyler Hudak on the Pluralsight malware analysis pathway. And as with all malware files, this is a real malware file. Please, if you do download it, be careful how you handle it. Do not launch it in production or a live environment. As you can see, I am launching it in my sandbox that is totally segregated from the network. I will not be responsible if you cause any harm or damage to your files or system while you're running this file. Neither will Tyler Hudak, who originally provided the file. As with every malware file, there are some precautions that security analysts take. The first one, which is the most important part of it, is to make sure that all files are zipped and have a password. This file's password is, let me just try to unzip that. So I'll extract files here. Let's go with that. Password. All right, so password is now Pluralsight, as you can see in there. README, have a quick read. It's meant to be used for educational purposes only. Use 7-zip if you have any issues. So we will extract this file. Password is Pluralsight. And there is our file. We can copy this to the desktop. Yeah, we can replace the file. So now we have our file on the desktop. Here it is. Quickly, how do we identify the file? I'd say the first thing is to run it through exeinfo just to see what we're dealing with. And as you can see, the file is packed. So exeinfo shows us that the file is packed. Please bear with me while I take some screenshots for my documentation. So first try, file is packed. Not bad. Exeinfo has given us that we can just run ubx to unpack it. Go into CMD for that. Let's type in ubx because this is Flare VM. Flare VM is an OS operating system for malware analysis, so it has a lot of tools pre-installed. You can literally just type some of these commands in there and it will run. For other VMs or other operating systems, you have to run it, install them yourself. So UBX, just type in UBX. You can see that. All right. So, okay. I'll just do a dir just to see where we are at. CD desktop. So we have a file here, financials XLS. So we do UBX -t -o, because I want to rename it, I'll put it to mfile, and then the name of the file, and that is done. If we go back to our desktop, we see that mfile has been created. And if now, so this was the first side. If we now run this through xinfo, we see that it has now, it now shows that it has been unpacked. All right, I'll also take screenshots on that. And throughout this analysis, because I have now created another file, I'll be doing comparisons throughout. So that will be good for documentation. So we have the packed file and the unpacked file. So let's go. Now, if we do run through CFF Explorer, this is the unpacked file, and for the packed file, CFF Explorer as well. We then notice they're coming into the file header, number of sections, etc, section headers. For this, we have the section headers, txt, data, text, data, and resources. And for the packed, we have UPX0, UPX1, resources. Just goes to show that. Then we move into PEStudio with the unpacked. PEStudio, within there we can see the timestamp, the compiler stamp. Again, this is just it's not authoritative. It's not confirmed that that date was when it was created, because the attacker can as well change it. We can go do a quick run through PEStudio, go through the optional header, check the sections. As you can see, it already states here, so PEStudio is pretty smart and has told us that this file is a self-modifying file, and that means most likely during the execution, when we do the dynamic analysis, we should watch out for how the file changes. So sometimes attackers get the file or the malware to adapt to what it notices in the environment. So you can also get that if you don't have the self-modifying tag, you can guess from if it's writable. So within the sections, the text section should be executable and have some initialized data. However, this is writable and executable, and PEStudio is going to have to add a self-modifying tag on there. Notice that the data section is just writable and has initialized data, and the resources tab only has initialized data. We can go into resources to find more about that. Clicking resources, we see that it has an icon, it has a dialog, a box, and then it has another icon. Now, a good one to note here, as PEStudio has also noted, is that there's a language in there, and this will give clues to where the malware was created, seeing as the resources take on they just inherit the language for the system. So you seeing that it is Russian, most likely was created with a PC or a computer or a device that has Russian as the primary language. Again, this can be modified by the attacker, so it is not final. We can just make a lot of guesses while we do the static analysis. You can go ahead to check resources, has import name, directories, however. You can go ahead to check libraries. As you can see, some of the libraries that are used in the file. You have the wsock, the kernel 32, advapi, you know, this these two, kernel 32 and advapi, are almost expected in any executable. However, what we can do is if there are any confusions, we can always go to MSN to read about it. So Microsoft, you can just go to Microsoft to read more about it. MSDN, I believe, social MSDN, right? And then you can search on kernel 32.dll. I believe that works, right? And there's a ton of information on kernel 32, the functions in there, identify the functions, what the DLL is for, what the library is for, uh, you know, just loads and loads of information. I would definitely be reading these as well just to understand more about these DLLs because I'm also a beginner. Then we can move into imports, importing APIs or functions. PEStudio does an amazing job, well, pretty good job, amazing to me, with linking the functions and APIs with the DLLs, right? So we can just get an idea from here to see what type of function or what type of activity the malware would do. So we see that from user DLL from advapi, it's deleting a registry key, it's setting registry value, it's deleting registry value. Note that these are numbers. Now, so for threat actors usually do this to confuse analysts. You can either call an API or a function in a registry using the registry name or using an ordinal. And an ordinal is a number assigned to that particular registry in the memory of every Windows OS, right? When we do the dynamic analysis or when the malware eventually runs, Windows then assigns the memory address using the ordinal or the name. As you can see as well in this tab, PEStudio has gone ahead to show us that these are ordinals, and that's really nice. To learn more about ordinals, again, PEStudio has shown us or given us that you can just click on this to go, but because we are not connected to the internet, it will just die here. However, we can go to MSDN and search for ordinals or registry key, or functions or APIs. We see here that this would most likely terminate a process. All right, so for kernel 32, you can write a file, it's going to delete a file, it's looking to, get some environmental strings, it's going to open a window if it's visible or not, it's going to try to allocate some memory, close registry, create a registry key. Yes, it's going to read file, get file size, create file, create directory, just do all sorts of things. Exit a process, going to most likely create threads, and the list goes on and on. All right, I think that's the end of the list, right? And then we can go on to check strings, right? Now that we sort of have an idea of what the malware might do, we can then have a look at strings. Here it's not calculated the size, but we see that straight up, we found a couple of strings here that look interesting. So this might be the C2 IP, and since within WinSock it's importing some network functions, network APIs, we can then assume that it would call out to this IP address. So watch out for the dynamic analysis for that. During the dynamic analysis, we see an HTML string. We see it calling some registry keys, so internet settings, checking for general desktop, uh, referencing some policies in the system, Explorer policies, Active Desktop, software install, so it will most likely try to install something. And then we see those APIs as well, some of the APIs that we saw in the imports. Again, these have been extracted from the malware code itself. Right, so we see get HTTP download Brave Sentry. That means it would try to go here. So we have another URL that we can put in as our IOC. Then, so Brave Sentry, and then we try to install calls to all those. So we have to watch out for that. This C Windows, to get into C Windows, you need admin privilege. So it would most likely try to elevate privilege as well. We see Brave Sentry again. There's a lot of focus on Brave Sentry, so it would means it will most likely download it, try to install it. So you download Brave Sentry, try to install it, and then put it in this folder and then launch it. Okay, we see a couple of other functions, APIs, create file, command line, quite interesting here. And then we see some errors, not enough space, no inputs, outputs, unable to initialize heap. Then from here on, and I believe we see a lot of dummy strings that don't exactly mean a lot of things. All right, create our log program. All right, so this is quite interesting, right? So we see this, and it looks as if this file, once it gets into your system, will throw a pop-up to tell you, so it's like a JavaScript window, throw a pop-up, say, your computer is in danger, Windows Security Center has detected a spyware, and would try to get you to click, right? So again, this is part of social engineering, trying to instill fear in you for you to click it. And we see that these are sentences that have been broken into different lines, just so it's more difficult for security analysts to understand. So we see your computer is infected, Windows has detected spyware infection. It is recommended to use special anti-spyware tools to prevent data loss. Windows will now download and install the most up-to-date anti-spyware for you. Click here to protect your computer from spyware. And again, yeah, it's part of social engineering, trying to instill fear in you for you to download it. And once you click that, you have to give it admin privilege, which is why it is how it will get the privilege escalation, right? So you have to click it, and once you click it, it will tell you, do you want to install this? You need admin privilege, and then the pop-up, you click yes, and boom, it can get into your Windows update from there. And then we see some more. Okay, we see Brave Sentry coming up again. Brave Sentry, very interesting. So again, this was broken up. So software, Windows, current version, run. Now this run is also important because run is what uh, the PC uses for, or threat actors use for persistence. So it will most likely try to launch at startup every time, even after you shut down. Right. All activities for this application, Windows security alerts, warning, components have changed, hidden process, right? And then it's answer the next time, use this window, your computer is infected. Yes, and then we see some others. And that is the end of it. Now, for this string analysis, which sort of looks, relatively okay on this front, we can use IDA as well. So IDA is another tool that can be used that sort of, paints an interesting picture of it. I would just let's load resources as well. So we have a view here, and this is the graph. All right, so public starts. Uh, most of these are, well, not most, all of these are in assembly language. Quite interesting. We can do the hex view. We can check the structure. All right, we can check the structure of it. Exceptions, registration. We can check enums. Some of these would probably understand if you have a programming background. We can check imports. These would be similar to the ones we've seen in PEStudio. PEStudio sort of makes it more, I don't know, more interesting to look at. Then we can check exports. This is exporting start. I have no idea what that is. I would be reading up on it later after this video. I will most likely put that in the write-up the reporter will be doing on this. I just realized that I have not taken a lot of screenshots after the exe info. However, let's pop back in the X view. Now this is the hex view, right? Scrolling up, it looks like lots of jargons. Just try to focus only on the blue part. This is a lot of, hex that we don't want to see. If we keep scrolling, I'll just go here. Keep scrolling. Right. So now we see a lot of things we can read. So we have kernel 32, advapi, comctl, you know, we see a lot of the DLLs. So this is loading the DLL as well. And then the API, so get module file name, get module handle, write file, read file, and that list goes on, exit process, set handle, it goes on and on. And these things we have also seen in PEStudio. So delete registry key, set value of a registry key, delete registry value, create registry key, initialize common control, co-initialize, co-create instance. It's a lot of fun. Translate message, dispatch message. It's a lot of good fun in here, right? And then we've got some more zeros, some more. Let's keep scrolling. Right, and then we've got here again, we've got the HTML that we already saw, the JavaScript line where it tells you, so this is all HTML and JavaScript, just rendering the frame, I believe, for the pop-up, and then your computer is in danger, right? And that is bold, and then line break, Windows security center has detected spyware, okay, or hardware infection. Line break again, right? It is strongly recommended to use special anti-spyware tools to prevent data loss. Table, table, table. Then that goes, what else on there? And then here again, we see it that, okay, get download.php, go to HTTP, host is download Brave Sentry, and then again, it's calling out to this. So it's getting a file from this IP address, right? So this URL IP address, and then download Braves entry. Like we said, Braves entry, right? No cache control. Enable software, Microsoft Windows, internet settings. Again, bring this. We see that alert again to instill fear in you. And then click here to install the latest protection tool. Right, so you're clicking there and then it's installing in your program files Braves entry as bravesentry.exe. And then your computer is infected. Windows has detected, that goes in again, right? And then you've got some wallpaper just to make it look legit. We see here again the Internet Explorer registry key, desktop general wallpaper. So you're setting your wallpaper. It's doing stuff with your, active desktop in your system, registry key. Right. So it's a lot of interesting things that it's doing here with the registry. And this just gives us, good guesses on what the file is actually doing. Again, so all right, so we're going to the software, registry key, Microsoft Windows current version, and running, and then we're going into c.windows where you update your XP update or exe where you would need the elevated ID, elevated privileges. And I think that might be the end of it. But let's keep scrolling. Again, we're only halfway, so it might not be the end of it actually. So keep scrolling. Nothing to see here. Nothing to see here. Again, nothing to see here as well. All right, seems we're at the end of that. So that's how to check it in either Pro or either Free on here. Quick one, I would like to just do another random check. So I'm putting this in HashCalc to get the MD5 hash, SHA-256 hash as well. Calculate that. I'm going to copy this, Control C on there, and I'm bringing up my browser, and I'll go into VirusTotal. So I am now on my host, checking VirusTotal. Here we are. We've got this here using the hash. We have 40 security vendors and one sandbox. We've got some more details on there. The MD5 hash, SHA-125, SHA-1 and SHA-256 in there. And then we also see the creation date, so we might actually be correct. However, this is what everybody says. So the names, popular names that's been called. This is most likely the 256 hash, right? So the 256 hash, XP updates, financials. If you remember, ours is called the financials. Oh, can't find this anymore. Interesting. Right. Okay, so portable executables. It's showing more information about the compiler, how it was compiled, what processor the target machine is for, the sections. Yes, we were able to see these three sections, and the imports as well. Um, yeah, resources, and then of course the Russian language in there. So it gives some good info about it. Relations, not much. One good thing. So if we check the IP address, do we have the IP address here? All right, so we have the IP address here. I believe if we scan on here as well, if we just search, we'll get something similar. Okay, so registry key is opened. I believe this is from the dynamic analysis that VirusTotal guys have, updated it from. some of the registry keys. Registry key set, so it's setting the Windows Update Loader, which means it would be in your XP update, right? Path created, processes terminated. We can read more about these processes just to understand what it does exactly. And I think that's all. Um, I will now work on my write-up and try to put as much information on there as possible. I hope this has been helpful for everyone. Thank you.